Hello, everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 4A. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 8th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2024, Pune, India. The 8th edition of the conference is being organized in a hybrid mode. The physical event is organized today in Pune, India, and the virtual event was held through Zoom yesterday and is taking place today, that is 12th and 13th of January 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we will have 10 presentations. Each presenter will be given 8 minutes for the presentations and 2 minutes for the question and answers. On 7 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session, Dr. Anubha Jain, currently working as an Associate Professor and Director, Department of Computer Science and IT, IIS, located in Jaipur, India. An academician for the last 22 years, she has actively contributed in teaching, industry, and R&D. Her research interests include soft computing, computational studies, IoT, and software engineering. She is the author of 9 books and has published a number of papers at the international and national level. We welcome you, ma'am.
Thank you.
Thank you, ma'am.
Very good morning to everybody.
We'll be beginning with the papers. We have a first presenter for the session, Shikha Verma, with a paper titled Artificial Neural Networks Based Forecasting to Anticipate the Indian Stock Market. You may start with your presentation. It seems we do not have ma'am here with us till now. We'll be moving on with the next paper. Presenter Sarika Swami with the paper titled Correlation of Emotional Intelligence and Perceived Stress, a Comprehensive Analysis. Ma'am, if you're here, then you may start your presentation. Even Sarita ma'am is not here. Sir Vijay Siva. Do we have Pranav, paper presenter Pranav? Moving on, we have our next presenter, Vedant Jagtap, with the paper titled Leveraging SEU Data Factory for COVID-19 Data Ingestion, Transformation and Reporting. Sir Vedant, if you're here, then you may start with your presentation.
I think he's here, yeah.
Yeah. Sir Vedant?
Hello. Yes, my group members are yet to join. So what do I do?
So how much time will it take for them?
Wait for some time or someone is ready with his or her paper.
Or we have Arko Propo Ghosh.
Yes, I am ready, so I can start off with
Okay, sir, please begin your presentation.
Yes, I am starting.
We have Sir Arko Propo.
So, just 1 minute. So, can you just tell me whether my mouse pointer is visible?
Yeah, it is visible. Please go ahead.
So, thank you everyone. So, I am Orko Profakos, and today I am going to present our paper titled Novel Statistical Glaucoma Prediction Algorithm based on spectral analysis. So starting off with the table of contents, this is what I will be going throughout my entire presentation, starting with motivation. So coming to the motivation, the high prevalence of glaucoma. So we have seen that in India, about 12 million people have been suffering from this disease, and it is expected that worldwide this number will go up to 111.8 million by 2040. So there's a very pressing need for an accurate and efficient algorithm. Coming to the age and risk factors, we have seen that people above the age of 60 have a higher chance for developing glaucoma, and hence we need a very early detection algorithm. Coming to the limitations of the currently present machine learning models, most of the machine learning models rely on resource heavy setups like GPUs and are not at all economical and eco-friendly as well, because they leave behind carbon footprint. And coming to the contribution to healthcare accessibility, the researchers have aimed to contribute to healthcare accessibility by preparing an algorithm which can be used for in areas or the communities where the presence of very high infrastructure or specialized medical professionals are limited. So we have developed an efficient and accessible algorithm that is based on the fusion of image processing, spectral analysis, and advanced statistics. The use of colored fundus images have made our entire algorithm much more economical and cost efficient. And we have used the statistical measure of KL divergence to predict the presence of glaucoma, and hence have achieved an accuracy of 76%. Coming to the data set, our data set comprises of 98 colored fundus images, among which 31 are normal and 67 are glaucoma. So coming to the research novelty, the team of researchers have come up with an table-driven approach for the prediction of glaucoma, and it is arguably for the first time an entire algorithm for the prediction of glaucoma is based on signal processing, spectral analysis, and advanced statistics. As it is based on these signal processing, advanced statistics, and spectral analysis, so it's totally based on equation, which makes it much more robust and has less computational complexity. The GPU requirements are moderate. So this is the entire proposed algorithm, and I will be going through each and every part one by one. Coming to pre-processing, it involves noise removal. It is done with the help of a non-local means algorithm, or NL means algorithm, which has two modes of operation, that is slow and fast. For our model, we have used a slow mode of operation, which results in improved image clarity and is helpful for the further steps. Coming to the training dataset, we have randomly taken the 70% of the entire dataset as the training part. This starts with the optic disc segmentation. This optic disc segmentation is done to isolate the optic disc region of the denoised fundus image, which helps us to facilitate in the further spectral analysis part. The spectral analysis part start with the FFT, or fast Fourier transformation. The fast Fourier transformation transforms the entire fundus image in between the spatial and frequency domain. Upon performing the FFT, we get the magnitude spectrum, which helps us to get the one-sided and two-sided PSD. Upon receiving this PSD, or the power spectral density, we normalize it so that we can bring it down to one scale. And as we are using an image, so it is present in the form of a 2D matrix. Hence, to get the probability distribution array, we need to transform the 2D array to a 1D array. And finally, the KL divergence score between two images is used for the prediction of glaucoma. So coming to the decision mechanism, now I have been talking about KL divergence. So let us understand very briefly what it means. So it is nothing but a statistical measure about how two probability distribution arrays are different from one another. So to get two probability distribution arrays, we need two fundus images. So let us understand our algorithm. In our algorithm, we are using two fundus images to get the KL divergence score. So for our algorithm, what we have done, we have referenced or standardized one of the image as a normal image. The second image is, however, the input of the patient. So it might be a normal or a glaucoma image. So what happens is that the type of combinations that we receive is that it is a normal with versus another normal image, or a normal image versus another glaucoma image. In our training data set, we had 21 normal and 49 glaucoma images, and hence the combination stands as, for normal versus normal, we had 441 combinations, and for normal versus glaucoma, we had 1029 combinations. So the KL divergence score is now normalized and then rounded up to 3 decimal places. So this is how the entire KL divergence scores look like. So the one above is a snippet of the normalized normal versus normal score. The one below is of the normalized normal versus glaucoma. So let us understand this scale divergence score. So here we see that the image numbers are present on the columns as well as on the rows. So one on the left these are all the normal images, and we have done the scale divergence of the entire data set with respect to the normal images. So for example, we receive a value 0 as a scale divergence score. So the value 0 means nothing but that both the images are equal or almost equal. So the prediction will be a normal. And in case we receive a value 1, that means if we receive a value 1, then what happens is that both the images are all totally different. Hence, the prediction will be a glaucoma. And now let us understand all these values what we are also getting, like 0.965, 0.063, 0.038. So for these values, what we are doing is that we are dividing these scores into 3 other bands. They are 0.x band, 0.0x band, and 0.00x band. So what does this band depict? So any value such as 0.1, 0.2 will fall under the 0.x band. Any value of 0.01, 0.02, up to 0.09 will fall in the 0.0x band, and any value such as 0.001 up to 0.009 will fall under the 0.0x band. So this is how the bands look like, and in every band we have calculated the frequency of occurrences. So for example, in normal versus normal, we have seen that the value of 0.1 has occurred 9 times. So the frequency is 9. And we have also calculated the percentage of occurrence. The percentage of occurrence is nothing but the frequency divided by the total number of combinations. So what we have done is that upon receiving the percentage of occurrence for both the cases of normal versus normal and normal versus glaucoma, for every band we are comparing it. So in case of 0.0x band, for x equal to 1, the percentage of occurrence for normal versus normal is 2.04%, and for normal versus glaucoma it is 0.09%. So what we see is that this value is almost 21 times of this. So it is much more dominant. So during prediction, if we get any value of 0.01, then we will predict it as normal and not glaucoma. And similarly, what we can see for 0.02, the percentage of occurrence is 1.5%, whereas in normal versus glaucoma, it is 10.5%. So we will be predicting it as glaucoma and not as normal. But in some cases, we find that this percentage of occurrence is almost similar. Like in case of x equal to 3, we find that the percentage of occurrence for normal versus normal is 0.45 and the percentage of occurrence is 0.29. So it is not even, the rate of change is not even 50%. So in such cases, we have developed another algorithm, or the favorable judgment algorithm. So in cases when the conflict arises, we will take help of this algorithm. And what does this algorithm say? Let us understand. So in 2020, we have seen that approximately 12 million people were suffering from glaucoma, and the entire population of India was about 1.3 billion. So approximately we get about that 0.8% of the entire population is suffering from this disease. So for a conflicting region, this algorithm gets triggered, and we see that 0.8% is actually very negligible, and we will be predicting this band as a normal band. So in case of for 0.03, what we have done, we have predicted it as normal, but FJA in bracket, which implies the favorable judgment algorithm. Also, another case that might arise is the out of bound algorithm. So let us understand what it is. So what we during the training phase we have observed for the band of 0.0x, we have observed the value of x from ranging from 1 to 5. But it might happen that during prediction we get a value like 0.07, like 0.08. So it hasn't occurred during the time of the training. So what we will do is considering the safety of the person, we will predict that particular band as a glaucoma, and a traditional glaucoma test will be advised. So coming to the prediction dataset, the similar procedure that we have just done with the training phase is also performed on the prediction dataset. And upon receiving the KL divergence scores, what we do, if there is no value mismatch or no conflict, then the table-driven judgment algorithm that I have just explained gives us the result. In case of the value mismatch, the OOB or the out of bound algorithm gets activated and the result is glaucoma. And if a conflict occurs, the FJA or the favorable judgment algorithm is activated and the result is a normal or non-glaucoma. So these are our results. The accuracy is that we have received is 76%, F1 score of 82%, sensitivity of 86%, and a precision of 78%. And the computational time during the training phase for is about 51 seconds, and for the prediction phase is 11 seconds. So it is a very fast process. And coming to the discussions and future work, coming to the boundary decision thresholding, in future what we can do, we can prepare a automated boundary decision thresholding technique rather than the manual decision boundary thresholding technique that we have currently done. And this will help us in improved accuracy and will make the entire procedure much more faster. It is a very easy to implement and can be implemented without the help of any highly specialized medical professional. Overcoming the algorithmic complexities. Algorithmic complexities. So we have a very entire total algorithm is based on equations, so it makes it much more robust, and hence that is very less complex. And expanding our data set, we will have an improved accuracy, and we can also use other divergence approaches like the Hausdorff distance or Bhattacharya distance, which can be implemented so that we get a better and improved accuracy, and also it will get we can get a better insight about the scores that we are getting. Coming to the conclusion, we have an innovative fusion approach which involves the spectral analysis and advanced statistics, and has a good efficiency, and also provides an environmental impact that we don't produce any non-eco-friendly carbon footprints like that we are seeing on the current machine learning models. And so these are some of the selected references. And coming to the supplementary information, we haven't received any form of funding during the entire research, but we will be really thankful to the scientific lab of image and signal processing of Heritage Institute of Technology, which has helped us a lot during the entire research. And so I'm really thank you for having such a wonderful audience, and I will be taking up any questions from the audience now.
Hello, can you hear me?
Yes, ma'am.
Yes, sir. It was a very good research. Tell me one thing. Have you thought of any future work for this particular research? What are you going to do in future?
Like in future, for improving the our entire mechanism, we have I just told, like we can use the other divergence approaches like this Hausdorff and Bhattacharya distance, and expanding our dataset scope. But like it can be also implemented like a model, like we can do it for in areas such as the remote areas. This can be a very useful work, like it can be done without.
This is a very good application based research, so I think you should extend it further.
Yes, ma'am. Surely I will be taking this feedback very important. Thank you.
And have you tried any other algorithm other than spectra analysis?
No, ma'am. Actually, during the when we were doing the research, before starting the research, read various research papers, and a lot of research papers involve the machine learning and image processing. But arguably, like for the first time, we have been using the entire process under the spectral analysis and statistics. So it is I think it is a totally new approach for prediction of glaucoma. So we haven't
That's
actually.
fine, but you need to validate your research. So you need to compare it with other resultants also. So I think maybe you can try one or two more machine learning algorithms, or maybe with the existing researchers, you have to
Yes,
compare your
yeah,
algorithm properly.
yes, ma'am. Sure, ma'am.
So that is more important,
Okay, ma'am.
because ultimately that will let you know that is this algorithm better approach, or no, you need to go for something else.
Yes, ma'am. Sure, ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am. We'll be proceeding with the next paper presenter, P. Servan Sri Sai, with the paper titled Smart Crop in AI IoT powered crop health monitoring system. So if you're here, then you can start your presentation.
Okay. Good morning, all. This is P. Sarvan Srisai from Amrita Vishwa Vidyapeetham. Today, I am here to present you a paper titled Smart Crop in IoT-powered crop health monitoring system. First of all, let me introduce the idea behind this paper. A game-changing IoT-powered crop health monitoring system that boosts farming precision using real-time data. Smart Crop enhances crop health, resulting in a remarkable 30% increase in yields, achieving a 95% accuracy in early disease detection and reducing water usage by 20%. This cutting-edge technology not only to maximizes productivity, but also promotes sustainable farming, joining us in shaping the future of agriculture. Uh, Now, introduction. Smart Crop, an revolutionary IoT-powered crop health monitoring system designed to elevate contemporary agriculture by integrating essential sensors and advanced technology. Smart Crop excels in monitoring environmental conditions and crop health. Its key features includes precision irrigation, rapid threat detection, and real-time data on temperature, humidity, and soil moisture. Farmer can conveniently access this valuable information through a cloud platform, empowering them to make informed decisions from sustainable and resource-efficient farming. Smart Crop not only enhances crop quality and yield, but also aligns with eco-conscious practice, contributing to water conservation and reduced pesticides use. The main SDGs addressed in our contributes to SDG 2, Zero for Hunger, by optimizing crop yield and quality. Additionally, it supports SDG 13, Climate Action, by enhancing agriculture resilience, and SDG 15, Life on Land, throughout of biodiversity friendly practices. Lastly, the initiative address SDG 9, Industry, Innovation and Infrastructure, as a 10, sorry, as a 10 state as a ten, sorry, as a testament of its commitment to technology-driven agriculture innovation. In this research, we concluded layers of strong groundwork for the development of smart crop. We looked at various studies that focuses on smart irrigation, diagnosis, crop health, and using machine learning for monitoring irrigation. These findings help shape smart crops' overall approach, integrating the cheap, like most effective practices and the latest advancement in the field. Smart Crop has various functions such as real-time monitoring. Stay informed when the live updates on the system, ensuring farmer to have the information at their fingertips. Precision irrigation. Optimize water usage with targeted and efficient irrigation practices tailored to specified. Remote accessibility. Access and control the system from anywhere. Alert and notification. Receive instant alert and message keeping farmer about the motion. Customizable thresholds. Tailor the system to your preferences and requirements. Data analytic dashboard. Gain valuable insights in your agricultural operations through a user-friendly dashboard, facilitating data-driven decision making. motion detection. Enhance security and motion capabilities by detecting motion, adding an additional layer of protection to your agriculture assets. The methodology section holds system setup, hardware. We begin with the foundation or IoT hardware, cloud infrastructure, and user interface. This robust combination ensures a stable and efficient system from end to end. Sensor deployment, strategic placements of sensors, meticulous data collection, and precise collaboration from the bedrock of our data acquisition strategy. Data transmission processing. Transmission. Security is paramount. Our system employs a secure communication protocol to ensure that data travels safely from the field to the cloud. Storage and processing. Once in the cloud, data finds its home in a secure storage environment for algorithmic analysis and machine learning capabilities, then kick into driven valuable insights. Crop health analysis, data integration. We take a holistic approach to crop health assessment by integrating data from various sources. This comprehensive view allows us to make informed decisions about the well-being of crops. Models. Machine learning takes center stage as we train models to recognize patterns and enable accurate and predictive insights. User interaction and alerts. Our user-friendly dashboard provides a window to the agricultural landscape. User can navigate through the data effortlessly, gain a deep understanding of their crop health. Alerts. Timely notification and crucial. Our system is equipped to deliver critical issues, alerts, and actionable recommendations, ensuring swift response to potential problems. Field testing or evaluation. Pilot testing. Uh, Real-world trials are integrated to our methodology. Practices application is required to gather valuable user feedback during this phase. Performance evaluation. System optimization, feedback loop. We establish a feedback loop in correcting user insights and technology achievements to refine our system over time. Scalability. The system is optimized to scale and we proactively manage and optimize cloud resources to accommodate increasing demands. The main hardware used in our system smart crop are PHT11 sensor, which is used to measure the humidity and temperature, PIR motion sensor, which detects the motion, water pump, which turns on automatically when the soil moisture sensor detects the water level as low. ESP8266 model. It is also called the brain of our entire circuit, which helps to control the cir- cir- control the system. Buzzer which turns on automatically when the motion detector detects the motion LCD display. It is used to display the health status of the crop and the optimized values. It is used to control the low-end system with high-end circuits. Next, from this, we have achieved the results of real-time monitoring, continuous tracking of key parameters like soil moisture and crop health for immediate decision making in our management. Security enhancement, utilizing technology to promptly detect and address threats from pests and animals, safeguarding crop from potential damage. Automated irrigation management, technology-driven control of irrigation process based on real-time data optimizing water delivery for enhanced efficiency and crop health. Efficient resource usage, optimized allocation of water, fertilizers, and energy through data-driven insights and automation, promoting economic and environmental sustainable farming practices. These are the soil moisture levels of various types of soil where the water pump turns on automatically when it detects the moisture level below these values. In conclusion, the article emphasizes smart crop integrated approach using IoT technology in agriculture. By simplifying plant growth tracking, the system becomes a valuable ally for farmers, providing real-time feedback and automating critical process. Smart crop not only stands as a technological innovation, it also contributes to sustainability and food security in agriculture, supporting farmers and enhancing the agriculture landscape. Acknowledgement. We would like to convey our gratitude to our Chancellor Sri Mata Amritanandamayi for providing us a chance to showcase our efforts towards sustainable farming practices. These are the main differences that we have gone through our topic. Thank you. Hello.
Thank you, sir. Ma'am Madhubha, any question? It seems ma'am somehow disconnected with the audio. Thank you, sir.
Okay.
We'll be moving
Okay.
ahead with our next presenter. Sir Vijay Siva, if you're here, then you can start your presentation with your paper. Sir Vijay Siva.
If you'd like, I can start presenting also. I'm ready.
Yeah, sir, without no issues, please begin.
Can you hear me?
Hello, Anisha, can you hear me now?
Yes, ma'am, you're audible now.
Oh,
Okay, ma'am, can I mute and wait in the queue?
Yeah, sir,
I think
sure.
I'm
yes,
okay,
you
just
can
one.
start off.
Sir Vedant, are you beginning with the presentation?
Is my screen visible?
Yes, sir, it is.
So I am Vedant Jagtap, one of the contributors to the paper titled Leveraging Azure Data Factory for COVID-19 Data Ingestion, Transformation, and Reporting. First of all, we would like to thank SMARTCOM for giving us an opportunity to present our idea and for accepting our paper in the 8th International Conference on Smart Trends for Computing and Communications. So these are the following are the contents of our presentation. So to begin with, the COVID-19 pandemic has necessitated the collection and analysis of large volumes of data from various sources to understand its impact and make informed decisions. Uh, so this study explores the utilization of Azure Data Factory, a managed cloud solution for integrating and reporting COVID-19 data. These are the related works, and in conclusion, these studies collectively demonstrate the relevance of Azure Data Factory in the context of COVID-19 data integration and reporting. They highlight the role of cloud-based solutions in providing scalability, flexibility, and integration capabilities. The objectives of the study. The first objective revolves around the creation of a reporting platform for data analysts. Secondly, it establishes a data platform using Azure Data Factory to enable data scientists to leverage machine learning models for predicting the spread of the virus to gain insightful findings. So the proposed solution architecture is depicted in figure 1. So real-time COVID-19 data is ingested from the European Center for Disease Prevention and Control, also known as ECDC, and Eurostat websites. Once the data is ingested into the Azure Data Factory, it is transformed using data flows, HD Insight, and even Databricks. Once the data is transformed, it is ready to be published using a reporting tool called Power BI, and that is used by analysts to analyze different patterns. And all of the transformed data will be then stored into our data lake for use in machine learning models in the future. So data sources for population by age, we are using Eurostat website. And for confirmed cases, mortality, hospitalization, or ICU cases and testing numbers, we are using the ECDC website. So a methodology is proposed to employ a systematic approach to investigate the real-time processing and reporting capabilities of Azure Data Factory for the integration of COVID-19 data. So the first step is to ingest data from Azure Blob. So Azure Blob Storage provides scalable, cost-effective, and cost-efficient object storage in the cloud. With the help of copy activity, population by age from the Eurostat website is copied from blob storage in gzip format and extracted into the data lake in TSV format. So real world scenarios are also introduced, which production level data pipelines are expected to handle. So
Vedant,
yes, ma'am.
are you changing your slides?
Yes, I'm changing.
No, we cannot see the changed slide. Others, can you see it? Now you are changing the slide. Now we can see it.
Can you see it now?
Now, yes.
Now I was doing this.
But it was not visible. Only first slide was coming, so that's why I asked.
Okay, now is it visible?
It's visible now.
Okay, so like real world scenarios are introduced, which production level data pipelines are expected to handle. So the first one is validation activity. So if the data source has been made available by another system within the organization, it needs to be processed immediately. So this activity will check if the file exists using parameters like data set, timeout, and sleep, and specifying the file size. So get metadata if condition, and these are web activities. So now the task is to get additional information like column count, file size, etc. So if these conditions are satisfied, then copy activity is called, and the source of the file is deleted. Otherwise, the web activity is invoked, and uh, to build a logic app and send out an email. So the second data ingestion is from HTTPS. So 4 different files need to be downloaded from the ECDC website. And for each file, a pipeline must be created. But in that process, 4 new data factory components like 2 data sets, 1 copy activity, and 1 pipeline must be created. So in the case of 50 data sets, 200 new components will have to be created. So which is excessive. And the pipeline for data ingestion from HTTP is similar to the data ingestion from Blob, but includes advanced concepts that make it more scalable and performant. So activities like lookup activity. So lookup activity will fetch data from various sources. So these can include like database, files, or any other supported data sources. Then for each activity, it is basically similar to the for loop in any other programming language. And the activity takes in a set of values and iterates over all of them sequentially. So once both of these execute, the copy activity is then called, and data is then copied to the Azure Data Lake. So now we come to the first transformation that is taking place. So once the data is gathered, it is necessary to prepare or transform it to make it usable. So the first type of transformation is data flows. So in simple terms, data flows is used to visually design data transformation without writing any code. And multiple transformations are utilized, including filter transformation, that we want to isolate only a specific a specific uh, like a country. If you want to country or any city, we want to isolate that. So then select transformation, then it chooses the column to carry forward, drop unwanted columns and rename columns, and basically sort transformation is to sort the data or arrange the data. So the second type of transformation is HD Insight. So HD Insight is basically an open source full spectrum analytics, and it provides the total control over how clusters are set up. So HD and Insight, it uses Hive script, and the Hive script in HD analysis basically is setting up databases. It is creating tables for storing the COVID-19 related data, and it performs ETL, that is extract, transform, load operation, to process and store the testing data in a more organized and usable format. And the last but not the least, the third transformation is Azure Database Cluster. So it constitutes a set of computing resources and configuration, and the necessary transformation is splitting the country code and the age group, and excluding all the data other than 2019, because the spread of COVID occurred after 2019. and it also removes non-numeric data from the percentage column. So the next step involves copying this data to Azure SQL database that can be used for reporting. And now we come to pipelines. From data ingestion to transformation, all these processes are orchestrated through a pipeline. Therefore, it is necessary to monitor the pipeline.
Vedant, can you refresh your slides one? Again, it has hanged.
Why is it happening? I don't know.
I have no idea. Maybe internet at your end. I'm asking the same. Now results and discussions can be seen. Yes, now we can see your slides.
So please tell me if you're not able. I'll try
Why
to.
don't you go to the slideshow mode?
I am in the slideshow mode.
No, we can see the outline mode out here. Your slides are there in the left. It's not the slideshow mode. Anisha, can you hear me?
Yes, ma'am.
Can you see your slides changing?
Right now it's changing manually, but
Yeah.
before it was not changing.
It was not changing, isn't it? Yeah. Vedant, now you continue. Just do slideshow once. Let's see if it's going on the slideshow mode.
Is it visible now?
No. Have you shared the entire screen or a particular screen?
Entire screen. Hold on.
We cannot see your slideshow. It's in the normal slides view only.
Are you seeing this Safari?
I'm seeing the methodology slide. Copy data to Azure SQL. It's okay, you just keep on presenting, that's it. Please continue this way only, but change your slides manually. Yeah.
So where were we? So the pipelines, they are necessary as from data ingestion to transformation. All these processes are orchestrated through a pipeline, and therefore it is necessary to monitor the pipeline with monitoring capabilities integrated within the data factory itself. So the last step is to build a CI/CD pipeline, that is continuous integration or continuous deployment. So when building a project in Azure Data Factory, an Azure Resource Manager or ARM template is obtained. So the ARM template contains the project configuration in JSON format. So after testing, the ARM template is released and deployed into higher environments such as test and production. So let's come to the results and discussion. Now, is it visible now? Results and discussion slide.
Yes, it is.
Okay, so figure 6 depicts COVID-19 trends within European Union and United Kingdom for all countries. There are multiple components displayed using Power BI, such as total confirmed COVID-19 cases, total deaths, hospital occupancy, country selection, and the plot of total deaths displays the total number of reported deaths on a specific date due to COVID-19. So it also allows user to select a specific date range, and these visualizations are interactive features in Power BI and enables users to explore and analyze COVID-19 data dynamically, gaining insights into the spread of the virus. And the next figure is basically it's a pie chart. So it depicts the percentage distribution of COVID-19 tests conducted by different countries, and a line graph is depicted the comparison between number of COVID-19 tests conducted and the number of confirmed COVID-19 cases over time in European Union and the United Kingdom. So it can reveal trends and patterns in the data, such as increase in testing leading to a rise in confirmed cases or vice versa. Like the previous figure, there is a date slider that allows users to select a specific date range. Now, coming to the conclusion, by using Azure Data Factory, this study provides a comprehensive understanding of the capabilities of Azure Data Factory in real-time COVID-19 data integration and reporting. The findings will contribute to the field of data analytics and aid organizations in uh, leveraging effectively leveraging Azure Data Factory for informed decision making during any other pandemic. And these are basically the references. Thank you.
Okay, Vedant, you all are BTech students, MTech students.
BTech in computer engineering. We are
Which
in
year?
last year.
Last year. So this is a part of your project.
Yes, ma'am. This was a part of our project, and we decided to showcase the capabilities of Azure Data Factory. So that is why we decided to publish a research paper for this project.
Okay, but my question is that what is the benefit of storing your data in Azure Data Factory? It can be done in other maybe store management softwares, isn't it? I can use
Yes.
any good DBMS for the same. What is the difference?
Ma'am, when you want to scale the data, so you cannot there are diverse data sets, and most of them are unstructured. So the advantage of storing in Azure is like it collects the unstructured data, and then you can store it in structured format. So that structured format is necessary for proper analysis of the data. And like as we have considered real world scenarios, there are pipelines also for real time or batch processing. So if you want to scale, you have to handle large volumes of that data. So that will enable timely and accurate reporting.
I think that can be done by other technologies too. Did you
Ma'am,
read other technologies?
like you mean AWS, Google Cloud and all?
Yes.
Yeah, that can be done. But like AWS has better market share, but in terms of pricing structure, pricing is better of Azure and integration with technologies. So now we are using a Microsoft.
No, that is not the case. Are you sure what you are saying?
Yes, ma'am. Like when we were running the Databricks cluster, it was only 0.75 Databricks per units. So that was like 60 or 70 rupees. But in AWS, then it will charge you 120 rupees. And
Maybe
even
processing speed is faster.
uh, processing speed, like it depends on the number of clusters and what the cluster configuration is. If you want number of cores, then it
I
depends.
think the paper is good, but you should do a comparative analysis of different technologies too.
Okay. Yeah. Even like we are using Power BI, right? So there is seamless integration. It's a Microsoft
You are
product.
using Microsoft products, isn't it? So
Basic seamless integration.
at a particular point of time, you do need license for the same, isn't it?
Yes, we do need license for this.
So you have to pay. Are there any open source tools for data visualization? Can you use that?
Open source tools, we have only used this
Actually, you are
Power.
studying Azure and Power BI because both are Microsoft products, they go well hand in hand. But take do more research on other tools too, right?
Oh,
Because you're a BTech student, it's a good project, but research on others too. You should have a fair knowledge about other tools too.
yes, ma'am.
Okay, thank you.
Thank you.
Thank you, sir. Thank you, ma'am. We have our next paper presenter, Sir Vijay Siva, with the paper titled Impact of Internet of Things in Smart Agriculture. So you may go ahead.
Ma'am, am I audible?
Yes, sir, you are audible.
Um, um, my topic is impact of Internet of Things in smart agriculture. Can you hear me?
Yes, sir.
Okay. My topic is impact of Internet of Things in smart agriculture. And the presentation goes for an introduction, motivation, literature review, open research issues, conclusion, and references. And the Internet of Things is physical devices connected to Internet, which makes our life easier, which usually includes sensors, actuators, and much more devices, which makes our life easier. And when it comes to agriculture, the agriculture sector is greatly benefited by its efficiency, productivity, and sustainability of the futures of Internet of Things. Internet of Things can be utilized in smart irrigation, livestock monitoring, weather forecast, and much more applications in agriculture, which saves the resource food, and it is used to use the resource food in an effective manner. Effective manner. The following are the motivation for the research: lack of human resource available for agriculture, and wastage of this food resources due to delay in harvesting process. And human labor is expensive for agriculture operation, and automation of agriculture is required regarding process such as spraying of fertilizers. If it is too much, the crop is affected by fertilizer spraying when the person is not aware of the aware or experience of the fertilizer spraying process, and much more experience is required in the tasks such as weed detection and other process in agriculture, which can be automated using IoT. And these are the few literature reviews we have done so far. And Fada Lewis presented a new hybrid leader-based optimization technique with real-driven weed detection in IoT, which enabled smart agriculture with casual and WDSA model. And it has the results of the comparative research verify the superiority of suggested model over previous techniques. And in the future, the framework provider might be used for creating intelligent herbicide sprayers. As I stated earlier, fertilizer spraying is a curative task. The farmer needs an experience to spray the amount of pesticides. These type of algorithms and smart automation can save the crops by spraying fertilizers in the right amount. And Shwatik Tiwari et al. Done an integrated application of Internet of Things and digital image processing for wheat plant identification. He has investigated the study employ wheat using coordinate model to give you a full architecture of this technology in agriculture area. The regularized wheat coordinate is also intended for categorization using grayscale and color segmented. The weed detection is done using image processing, and as I said earlier, weed detection, fertilizer spraying are one of the most important tasks in agriculture, and the model has achieved an accuracy of 0.978, which should be greater than the traditional model accuracy with the grayscale separated images for weed images, which is 0.942. And Abdul Hazik Ishaq done an enhanced organic fertilizer blender using IoT, capable of remotely monitoring fertilizer output and sending updates to the workers for his research endeavor. When compared to the other automated systems available in the market, the prototype of automated organic fertilizer was saved five times the operational expenses when compared to the previous ones. And Arfat Ahmad Khan presented machine learning based fertilizer. It says real-time soil fertility context gathered using IoT, mapping to the increased fertilizer recommendation system accuracy. And the future scope is the production of IoT assisted fertilizer mapping is determined by comparing the suggested solution to usual soil chemicals such as nitrogen, phosphorus, and potassium. The findings of both approaches had a mean difference of 0.34, 0.36, and minus 0.13 for nitrogen, phosphorus, and potassium. Here are some. These are the open research issues in the IoT, that is interoperability and standards, lack of standardized protocols, and interoperability among different IoT devices and platforms in agriculture. Since IoT uses various standardized protocols, the competition major issue. Energy efficiency. Energy consumption of IoT devices, when particularly the IoT devices is battery operated, and they are when employed in remote locations where there is a power supply may be an issue. These things need to be considered when deploying IoT devices in agriculture. And optimized power saving techniques can be used to increase the lifespan and to reduce the environmental impact, because these are usually battery operated devices. And affordability and accessibility, the end users are usually farmers, so the designing of low cost sensors and financial models to make IoT technology more accessible to wide range of farmers is an important area need to be considered. And the environmental impact in manufacturing, deploying, and disposing of IoT devices is need to be considered, because these are electronic devices. So, the e-waste must to be reduced or recycled, which can save our environmental factors too. And I would like to conclude, Internet of Things is a promising technology that transforms existing farmers into smart farming by optimizing resources for human labor reduction, monitoring of crops, weed reduction, supply chain, and can be utilized in supply chain management for efficient utilization of resources such as fruits, vegetables, and much more. Harvesting of various crops can be physically demanding and can be result in injuries depending upon the type of crops. Automation of harvesting using IoT can reduce the risk of injury during harvesting, and it can also save damage of fruits like rotten or something by earlier detection using cloud platforms. And the usage of IoT by farmers can reduce the risk of injury to themselves or their workers. I have mentioned around 4-5 references over here, and that's it. That's it, ma'am. We can ask if you have any questions, please.
Can you show your experimentation and result?
Actually, it's just a review. It's not an experimentation paper. Just it's a literature review. It's a review on.
So, how many papers have you reviewed?
I have reviewed around 20 papers. I can't include everything in the slide. Around 25 papers. I can't include everything in the slide. I have mentioned in the journal. Around 15
Again,
papers. I have
don't you
included
think, for a review paper, 25 papers reviewing is very less?
Okay, ma'am. I will add more papers during my next review.
I hope, do you know what is a systematic literature review? Yes.
Okay, ma'am.
Okay, so my suggestion is please study about systematic literature review. And if you're preparing a review paper, it should be a proper systematic literature review.
Okay, ma'am.
Is it fine?
Okay, ma'am.
Okay, next one.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next presenter, Sarika Swami, with the paper titled Correlation of Emotional Intelligence and Perceived Stress, a Comprehensive Analysis. Ma'am, if you're ready, then you can go ahead.
Ma'am, can we share our?
Yes, ma'am.
Ma'am, we are different. We are NL2 code paper. Can we share?
Yeah, sure. No issues. Please, go ahead.
Good morning, everyone. Am I audible?
Yes, sir, you're audible.
Thank you. So the topic for our research paper was text to code generation, and the title was NL2 code, harnessing transformers for automatic code generation from natural language descriptions. So what we were trying to make was a code generator which recognized natural language inputs and converted them to their respective Python code snippets. So our research addressed the limitations of the existing methods. Like we already have many such solutions, but our main focus was to eliminate those and prepare a more advanced solution to it. So the major limitations of the existing code snippets were that they were incapable of capturing complex context and the emotion behind natural languages, because many a times we tend to write things in very natural, instinctive languages, which a program or a computer doesn't uh, understand as well. So the objective of our AI model, the objective of our AI model was to translate natural language code to the executable Python code, and we used the made that happen using transformer models, and we are now going to explain the transformer model for better understanding of the code generation.
Hello, I am audible. So we have used transformer model, which is a transformer model is a type of deep learning architecture that has revolutionized
So
the
the
field of
transformer
natural
model
language
is a
processing.
type of deep learning architecture that revolutionized the field of NLP, which is natural language processing. So we based our research on comparing different other processing languages as well, like RNN, CNN. But we found the best results with the transformer model, and it it has also been proven to be the best use, as many other systems which try to achieve the same aim have tried and generated successful and made successful code generators for the same benefit. So our transformer model was based on three main, like it's divided into three main parts: the encoder, attention mechanism, and decoder. So the encoder is like the input, and it uh, like if we say a English statement, it does the task of converting it into computer understandable terms, and then it gives those terms to the attention mechanism. And the main model is concentrated in the attention mechanism, which is attention mechanism, which is uh, which is based on vectors, and it considers the vectors of the encoder and then gives it to the decoder. The decoder's main task is to uh, concentrate all the vectors from the attention mechanism and put it into outputs into reader usable output form. So this is the diagram of our encoder, attention mechanism, and decoder. Now my colleague will take on from here.
Hello. Hello, I am audible. Hello.
Yes, sir, you're audible.
Yeah, so it transform model consists of three things: encoder, attention mechanism, and decoder. So in encoder, we have multi-head attention, feed-forward layers, and there is also called as positional encoding. So positional encoding uh, is a layer in which the text are used to be text are given numbers. So the model decides what text will be there in the sequence. So this is the results and evaluation. This is the evaluation metrics. We have used two evaluation metrics. One is perplexity and another one is accuracy. So the perplexity is type of evaluation metrics in that if the value or the number is lower, then the model is a good one. So we have achieved training perplexity of 15 and validation perplexity of 33. So this is the small screenshot of how the model works. So for example, if we pass an English statement, for example, write a function to find factorial of a number. So the output will be this. There, for example, in Python. So define factorial if n is equals to 1, then return 1, then return n into factorial. This is the sample code which our model has been generated. So our research aims to be first accuracy, to generate accurate code that reflects the user's intent. The second one is the efficiency. We aim to generate code quickly and efficiently without sacrificing our accuracy. We also, in future, we also, uh, uh, in future, we also try try to enhance our programming languages. Currently, we have only done for Python, but in future we are also trying to generate code for different languages such as Java, C++, and other languages. So we have also provided a user-friendly UI to make your user-friendly interface and optimize performance for different development environments. So our future scope is model enhancement. So our current model have complexity of 15, but we are trying to improve the accuracy as well. And also we are trying to use alternative pre-trained models. And other future scope is domain expansion, where we handle broader range of programming languages and adapting the model for different domains within the software development. Conclusion, the text-to-code generator using the transformer model has the potential to significantly improve the efficiency and accessibility of programming for developers as well as the non-programmers. By generating accurate and efficient code from natural language input, this technology could revolutionize the way the software is developed and expand access to programming to a wider audience. Thank you. Hello.
Thank you, sir. Anubha, would you like to ask any question?
Yeah. What are your future plans?
Our future plans is to expand our programming languages. Currently, we have researched about Python, but we are trying to expand to different languages, and also we are trying to improve our accuracy.
Okay. Are you also considering in terms of time complexity?
Yeah. In terms
Did
of
you
time complexity, yes, ma'am.
when you are expanding with different languages, each and every language takes different time to process.
Yes, ma'am.
You should consider that also,
Okay, ma'am.
right?
Yes.
Different programming languages take different time to process the same code.
Yes, ma'am.
So which language is better in terms of processing? That should also be considered in your case.
Yes, ma'am. We will do that.
Okay.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am. Ma'am Sarika, if you're ready, then you can start with your presentation.
Hello.
Yes, ma'am.
Hello, I'm audible.
Yes, ma'am, you're audible and your screen is visible.
Good morning, all. My name is Sarika Swami, and my today's topic is correlation of emotional intelligence and stress persist stress, a comprehensive analysis. These are my outline of research work. Stress has long been a major research topic in the field of health science. We can define our concept of stress as stress is how we react when we feel under pressure or threatened. It is usually happens when we are in a situation when we are usually happens when we are in a situation that we don't feel we can manage or control. And we talk about emotional intelligence. It is the ability to recognize, understand, and manage your own emotions, as well as being able to understand and influence the emotions of others. The relationship between stress and emotional intelligence is complex thing, but because several studies indicate a significant correlation between these two. The focus of this research is to investigate the relationship between emotional intelligence and stress and determine the major causes behind the stress. These are my objectives of research work. First, creation of data set for calculation of emotional intelligence and stress. Second, understand and analyze the correlation of emotional intelligence and stress. Third, understand the causes behind the stress. Fourth, analyze the result of this data using the classification technique. These are some literature reviews we have referred from our research work. This is the methodology of my research work. First, problem statement. In today's world, many people feel stressed out from school, work, and other life events. Therefore, it is important to detect stress at primary level. There are so many reasons of stress because it varies person to person. In my research, I have collected 3 data sets, that is EI dataset, PSS dataset, and SR dataset. After collecting a dataset, we applying a pre-processing technique for them to avoid the missing values and replace using central tendency mean of the data distribution. My EI dataset and PSS dataset total population is 105. EI dataset is a Mangal Emotional Intelligence Inventory dataset, which is developed by Dr. S.K. Mangal and Ms. Shubhra Mangal. PSS dataset is a Persist stress scale, which is developed by Sheldon Cohen. And after collecting the dataset, we measure EI and PSS using their standard norm table. After that, t-test is applied because it is a statistical method to use to compare the mean of the two groups and determine if there is a significant difference between them. After that, Pearson correlation test is applied to them to check the correlation of EI and PSS. Then we found 46 people found in a stress. We give one more questionnaire, that is SR dataset, and find the result and find the causes of stress, and then process, result discussion, and conclusion. These are my dataset information. How many rows and columns and instances are there? This is a PSS gender population. In 105 total 105 population, there is a 55% male and 45% female. This is age group wise analysis of population. That is 13.33 is adolescence, 66.67 is early adulthood, and 6.67 is a mature adulthood. 13.33 is a midlife. It is found that 28% having a low stress, 44% having high stress, and 28% of people having a moderate stress. This is a case processing summary of EI dataset and graphical representation. In my research, that is interpersonal awareness, and interpersonal management, and interpersonal management is there. Intra-PA is knowing about one's own emotion, and interpersonal awareness knowing about other people emotion. Intrapersonal management is managing one's own emotion, and interpersonal management managing other emotions. It is found that male having a better intra-PM and inter-PM as compared to female, and female having a intra-PA and inter-PA as compared to male. This is a graphical representation in detail. That is both male and female having a overall mean is 12.53, and both male and female having a 13.71 is interpersonal management, which is better than other emotional dimensions. This shows the detail of analysis of my result. This shows a graphical representation of all EI. T-test. This is a t-test which shows male and female differ significantly. This is a correlation test which shows that there is a perfect negative correlation between EI and PSS. Which is the graphical representation of PSS and overall EI score in detail. It is observed that subject 13, subject 88 and subject 99 are early adulthood, which is age group is 20 to 35 age group. If we compare these three with other 102 subject, it is find that it may be possible that this having a good EI, still they have a high stress after collect information. It is observed that because of workload, they find in a stress. This is a graphical representation in detail. Moderate stress, high stress, and low stress. This is a graphical representation of SR dataset why people having a stress. We find that there are 5 reasons people having a stress, that is workload, loneliness, social, study, and economical. And we find that 30.43 people having a stress because of workload. The accuracy was checked by applying classifier. The comparative study of this classifier was done where navy bias gave the highest accuracy. This shows the graphical representation between left measure and correctly classified and incorrectly classified graphical representation of 4 algorithms. This is my conclusion. I found that people found in stress, that is 44% in high, 28% in moderate, and 28% people having a low stress. Second is overall EI of people is average because inter-PA EI dimension is low. Third, there is a negative correlation between EI and PSS. Causes of stress is workload, because of workload. That is 30.43. It is found that the main cause behind the stress is workload. And finally, 4 classifiers were applied to see the accuracy of the conclusion drawn, out of which the bias net classifier showed the highest accuracy, that is 69.56. Therefore, it is proving that workload causes stress. This is my future scope. After detecting stress, suggest remedies and suggestions for that. Second, stress measuring devices or app can be developed in a future research work. Third, various methods of data collection may be used in the future research work, that is EEG, ECG signal, face recognition samples, voice detection samples, and other biometric information can be used for more accuracy in stress detection. These are my some references which I have referred for my research work. Thank you.
Okay, Sarika ji, I just want to know where did you take the data? Hello.
Hello.
Yeah. Sarika ji, where did you take the data set from?
Madam, I'm creating a Google form.
Okay.
And spread it on social media sites.
So
Like
is it a primary data set
Yeah.
for all the 3 categories?
Yes, ma'am. I find that EI data set, which is standard data set.
Okay.
Which is standard questionnaires, which is used for find the emotional intelligence of people.
Okay. That is a standard questionnaire?
Yes,
or you have
ma'am.
created your own questionnaire?
My own questionnaire is only third, that is SR data set.
Okay.
And 2
And
questionnaires are.
Rest you have taken from some psychologist or something?
Yes, ma'am. After completing my research, I validate my research from psychologist.
Okay. And there are so many different parameters for emotional intelligence. How were you able to limit your parameters?
Madam, it is vary person to person.
That's why I'm asking. There are a lot number of parameters. Are you considering all the parameters?
No, ma'am. In that emotional intelligence inventory, there mention only 4 parameters are there.
Okay.
And they suggest some standard norm table, how we calculate the awareness and management of people.
Okay. And how do you calculate stress? There is some standard formula for that.
There is one table that is answer and range. That is suppose if people find 1 minute, ma'am.
Okay. Thank you.
Okay, thank you, ma'am.
Thank you, ma'am. I'd like to announce the name of the presenters who haven't presented their papers yet. If we have Pranav Ranganathan, so if you're here, then you can start your presentation. Do we have Pooja Makwana? Ma'am Pooja? Sir Abhishek Kotari, paper presenter. Ma'am Shikha Verma? It seems we do not have our participants. This brings us to the conclusion of the session. I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 8th version and the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2024. I also thank the session chair, ma'am, Dr. Anubha Jain, for chairing this session. A token of appreciation to the chair on behalf of Team SMARTCOM 2024 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, ma'am.
Thank you, Anisha. Thank you very much. And I wish all the best to all the participants. They are doing good research work. All that is, they should consider different parameters too, as suggested. And I wish them all the best in the future. Thank you very much.
Thank you, ma'am. I kindly request everyone to switch on their camera for a quick snapshot of the virtual conference.
Okay, thank you so much, everyone. Stay safe and take care.
Okay, bye everybody.
Thank you, ma'am.